In this section, we're going to discuss the array list and some of its common methods. Arrays are wonderful structures. They're static. That means once created, they cannot be changed in size. The element values can change, but the number of elements cannot. If a programmer discovers later on that he needs a larger or smaller array, once it's been created, it's too late. So either a totally new array has to be created and values copied, or code has to be modified, recompiled, and then rerun. Awkward when you do not know the number of elements and find out that you guessed too small. Elements cannot be deleted from an array. If we have element values in one and we decide we no longer want that value, we have to go through convoluted methods of acting like we've eliminated the value. One thing that can be done with reference variables is to simply make them null, but we still have to test for null and iterate over null values. Still not quite what we want. Very few useful methods exist for arrays. We've used those, but an array is fairly limited. Java provides the ArrayList class. Objects of the ArrayList are dynamic in structure, which means they act like an array, but without all the limitations of an array. That is, the dynamic nature allows them to grow or shrink in size based on the problem. The programmer does not have to predetermine how many elements the ArrayList object will contain. If you discover late in the game you need more, you just add more elements. Elements can be removed from an array list, so if that value is no longer necessary in the list, eliminate it. You no longer have to iterate over it or write special code to test for it. And many useful methods are provided for ArrayList objects. Now here's something that is dated. That is, ArrayList objects can be generic. Back in the old days, they had to be generic. This means that every reference in an array list was object. And since every class subclass is object, an array list could hold anything. Problem with that is that you could mix types and not be able to handle all the types properly and cause runtime problems. When we specify the type on an array list, the compiler enforces that we allow only that type or subtypes of it in the array list. Therefore, we should be able to handle any element in it, particularly if the elements have polymorphic behavior. Since an array list is a generic container, we must tell it the type it's going to hold. Once told, it will allow only elements of that type or its subtypes in. We specify it most cleanly by saying array list, and in arrow brackets we say the type, give it a variable name, and assign it a new array list with empty arrow brackets, empty parens. That's the constructor call. It creates all the necessary elements of the object and allows it to hold the type that we specified. Some useful methods: add to insert new elements. They are appended to the end each time we do an add, although there is a way to specify the index. So like an array, we would insert an element at a particular location. Array list objects are zero indexed. Remove, we specify an index and it removes that element. Determine the size, whether it's empty. Get an object at a particular index. Set, we update the value of the element at that index. Determine if the array list contains a particular element value, and index of gives us the index where a particular value exists in the array. I mentioned polymorphism. Ideally, the creation of the array list should be hidden behind a reference variable of type list. Generally, we want to deal with the interfaces, and list provides a rich set of methods that we can call, and the array list implements those and adds more. If we need specific methods that the array list provides that list does not, we either downcast or we try to redesign our code. This allows us to change the actual implementation. We can change from an array list to a different type of list in our code and it still work exactly the same. Because an array list or any other container that implements the list interface is a list. It will do everything the list does. We shouldn't care about the actual implementation.